I wonder if they can see me. Let's see. All right. Whoa. There they are. Can you guys hear me? Can you hear me? Good, good, good. All right, sounds good. Let's see. So far, good. That's good. Didn't I tell you guys last week, even if you're not here, nobody's here, I'm going to continue teaching? It's just me. Well, 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 well. I have Caroline, Ghazi, Blake, Akane, Ray. A lot of people coming in. That's how it goes sometimes. So what I was planning on doing was giving a quick lesson, and then after the lesson, just tell me how it goes. Is that fine? You're going to ask me about those two, Ghazi? I don't care. You can see it? I sent you a link. You can watch the video. But, hey, come here. You guys, I got a special person here. You know this man? Do you know this guy right here? Hey, stay away. You're supposed to be 6 feet away. I don't want your virus. You broke your yogurt. No, never mind. There you go, Mr. Walla. See, somebody knows you.
Oh, so sweet.
One person knows you.
That's enough, okay?
That's enough?
Yeah.
All right, get on out of here. Walls, on your email, I sent you the link so you can watch along too. Just don't write anything inappropriate, please. All right, we got 2 more minutes and then we'll start. So I said 12 o'clock and we'll start from there. Just as a quick reminder, I'm not going to be here every day in this room. I have to leave tomorrow. So I was thinking next week, I'm going to go from the comfort of my home and I will be teaching you this way. Would you agree with that? Is that all right? Okay, good, good, good. The other thing is I'm going to try to do 2 different types of streams. So if people aren't able to connect somehow during this time, I'll save it as a video and then you can watch it anytime later. So that'll be one thing. The other thing I'm trying to do is doing Zoom. I don't know if people have heard of that. I didn't know about it. I didn't know about Zoom until somebody told me about it. So what I'll do with Zoom is I'll have the camera pointing at my desktop and I'll be writing notes down so you can follow along there as well. All right, so it's 12 o'clock. I'm going to start a quick lesson. We're probably going to spend about 15 minutes on the lesson. And then after that, just give me what you think, if I need to put some sound there or if I need to do something else. All right, Daria says there's good sound. Daria, there's good sound because there's a nice echo here when nobody's in school with me. All right. So I'm going to begin now. You guys can follow along if you'd like. All right. So, chapter 26. I gave you guys 3 questions. Did you get those 3 questions that I gave you from the textbook? Give me a thumbs up or a yes. Did you? Okay, good. So we're all on the same page because I'm going to go over those 3 questions. Really quickly as a review, we have current I equals dq over dt. So now I'm just going to begin. So we'll go from there. And then you can ask me anything you want after that. So I equals dq over dt. It's the rate of charge over time. And if the charge over time is constant, we can say that I is equal to the change in Q over the change in time. And there's a name for that. It's called steady state current. Okay. So you have steady state current. I don't know if you could see that. Let's move up a little bit. So steady state current is like that. And then we have I equals the integral of J dot dA. And this is the equation for the current density. It's how much current is going through a wire. So if you want me to review that, we can do that later. But for now, that was one of the equations. We also derived this equation right here. J equals N times E times VD. I'll write lowercase v there. So this was the equation for the drift speed. If you remember, in a wire, an electron has random motion speed. The random motion speed of the electron is 10 to the power 5. But if you want the electron to move from one side of the wire to the other side of the wire, it's going to have a bias towards the electric field. And it's going to move at this speed right here. And that's 10 to the power minus 4, roughly 10 to the power minus 5. So that's the speed, the drift speed. After we did the drift speed, we talked about Ohm's law, V equals I times R. And then we talked about the resistivity equation. Resistivity is inverse conductivity. So sigma stands for conductivity. Resistivity means how resistance charge is to, or current is going to flow, and conductivity tells you how easy current is allowed to flow. So this is resistivity, rho. We can also set that equal to the electric field divided by the current density J. So take the electric field in the wire. Here's your wire. Let's say this is a part of the wire. This is the positive side of the wire. This is the negative side of the wire. You're going to create an electric field going along this line right here. We call that E. And so the electric field, or the voltage, I guess, how are we going to write this? The electric field would equal the voltage divided by the length of the wire. So it's the slope of the voltage divided by the length. Okay? And then 3 more equations that you learned from chapter 26. One of them is the resistance equation. So resistance is equal to rho times L divided by A. And if you use this divided by this, you can actually derive that. We did that in class a couple of days ago. And then the last 2 equations are for power. Power is equal to I times V, the current times the voltage. That's the power in a circuit. So if I was asking you what's the power of the circuit, that's what you would use. If I said what is the power lost in a resistor, you would say that the power lost in a resistor would be I squared times R, which is also equal to V squared divided by R. Okay, so this is the power through the circuit, and this is the equation for power dissipated or power lost. And with this, you can also talk about the energy lost. So if I asked you what the energy loss was, well, power is equal to energy divided by time. So if we wanted to know what the energy loss was, we would use energy equals power times time, and you replace the power with one of these two. And that will give you the energy lost. Okay? How's it going so far? Does that make you following along? I'll wait for somebody to comment. There we go. You have a question about one thing. What's your question, Blake, about the one thing? Get out of here.
Yeah, what is your question, Blake?
What's that thing called? Social distancing? This guy has no social distancing. Oh my goodness. Go away.
Good luck, guys.
Where does I equal JDA come from? So it comes from the current density. So the equation, this is J. J stands for the current density. It's the current divided by some sort of space. In this case, it would be the current divided by the cross-sectional area. So it comes from J equaling I over that. So current density is, or charge density is the charge divided by the volume or the length. Current density would be the current divided by the cross-sectional area of the wire. So you take your wire and you look at this part of the wire, and that's A. So most wires are circles, so the area would be pi r squared. And then the current density equaling this equation right here, that's a whole derivation. I'll show you that later. But for now, that's the equation. Okay, Blake? Everybody else seems to be doing fine. All right. So let's move on to the next thing. All right. So we got a few more things going on here. Now they can see you.
Oh, really? Okay.
Yeah. Who's this? All right. So, okay, thank you. That is the density. Okay, sure. Yes. So now let's do some of the homework questions. We don't have homework. Well, technically now it's no longer classwork. It's all homework, isn't it? Let's look at some of the questions that I gave you. The first one was, I don't have the textbook. What was the first number? It was, I believe, number 29. So if you go to number 25, the question I gave you was a JPEG or image. When 115 volts is applied across a wire that is 10 meters long and has a 0.3 millimeter radius, the magnitude of the current density is given by that. All right. And they're asking you to solve for, find the resistivity of the wire. So this one is a pretty simple question here. They're asking you to solve for resistivity. What have they given you? They've given you the voltage, V, which is 115 volts. They gave you the length of the wire, which is equal to 10 meters. And they gave us the radius, the cross-sectional area of the wire. So the thickness of the wire is equal to 0.3 millimeters. And they gave us the current density, J. J is equal to 1.4 times 10 to the power 4 amps per meter squared. And you're asked to solve for what is the resistivity. So to solve for the resistivity, I'm going to use the equation resistivity equals the electric field divided by the current density. And so I already explained maybe like 2 minutes ago what the electric field across a wire is. The electric field across a wire is the voltage divided by the length of the wire. And so what we end up with is the voltage divided by J times L. So we know the voltage, we know J, and we know L. So you don't need to know the radius for this question here, or the cross-sectional area didn't matter. So plugging all of that in, if you did this, you end up with 8.2 times 10 to the power minus 4 ohms per meter. Good. I need somebody to write something, otherwise I can't continue. I don't know if you're still connected or not. Can I erase this? This part? This part? Can I erase this part here? Is that okay if I erase that part? All right, good, 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 good. Perfect. So we got 8 people watching right now. That's more than well, I think that's actually everybody. So the next question, number 51. Number 51, if we're looking at it together, you've got a 100-watt light bulb is plugged into a standard 120-volt outlet. How much does it cost every 31 days in a month to leave the light turned on continuously? So if you leave your light on for an entire month, how much moolah are you going to be using? So what do they say? The guap? The guap is going to be, we start off with the rate. So the rate is 0.06, that's dollars, I guess, over kilowatts times hour. So that's what we're starting with. That's what they gave us. We want to convert the kilowatts to regular watts. So you end up with, we want to get rid of the kilowatts there. So 1 kilowatt is equal to 1,000 watts. So the kilowatt cancel out. The next thing we want to do is figure out how many watts we're using. Well, every second we're using 100 watts. The next thing we want to do is get rid of this hour here because we just want to know the cost. So we got rid of the watts. We're left with this hour here. Right now we have dollars per hour. So how do we get rid of the hour term? Well, how many days are we going to keep it on for? There's going to be 31 days in 1 month. And 1 day is going to have 24 hours. So the hour here and the hour here cancels out. The day here and the day here cancel out. And we're left with dollars for every 1 month. Okay, it's just dimensional analysis. And when you work that out, you end up with a whopping $4.46. So, most of you are probably staying home now, so you'll probably have the light on most of the time. So there you go. 1 month, 1 light bulb is going to be that much. But this is a 100-watt light bulb, so We don't really use those anymore. If you are environmentally friendly, you're probably using one of those incandescent light bulbs, and they're usually about 20 watts or 30 watts. So about a third of this. So I don't know what you can get with $1 in New York City. Either way, good stuff, good stuff. Part B. What is the resistance of the bulb? So to solve the resistance, we can use the equation. So this is part B now. Power equals voltage squared divided by the resistance, R. And so rewriting this, we can solve for R. R is going to equal voltage squared divided by power. We know what the power is. It's 100 watts. So power was 100 whopping watts. And the voltage in the question, the voltage was, it's connected to an outlet of 120 volts. So 120 volts. And so you get the resistance. Something I just realized is a unit for resistance is voltage divided by watts. I didn't know that. You should get 144. What's that symbol right there? Ohms. Finally, we've got what is the current in the light bulb. So to find the current in the light bulb, well, we know power now. We know the voltage. We can use the equation. Thank you. Thank you. Thank you. We got ohms, ohms, and ohms. Just a FYI, there's a delay here. So when I talk, it's probably about 5 seconds until you hear it. Okay. So power is equal to I times V. You can solve for I. It's going to equal P divided by V. And you're going to end up with 0.833 amps. That might be enough to do some serious damage to you. So if you had about, this is just on a side note, if your current is somewhere between 54 milliamps, if you touch a circuit that has 54 milliamps on there, that will give you a little shake, right? If you touch something that's a little bit more than twice that, 120 milliamps, that's enough current to cause cardiac arrest and give you a little burn. So fun fact, don't do that. Finally, who's this guy? Would this video still be up after the live stream ends? Because I got here late. I don't know who you are, but yes. Yeah, it should be squared. What should be squared, Zoe? Shouldn't the 120 volts be squared? Yes. Good call. Thank you, thank you, thank you. See, this is good stuff here. Lastly, we have question 53. If you haven't looked at it yet, take a second to read the question and try it, and I will go over it as soon as I'm done erasing the board. So, Before we go on, I was thinking, because I've got all this free time now, I wanted to change my hairstyle. I was thinking of getting a mohawk like this and just cutting all this off. Any thoughts? Really? I think that's a great idea. Like that. There we go. Wow. Who said I don't have long? I don't know who this Wong person is, but how dare you? That's exactly why I want to get a mohawk, you see? There's no hair left here, but I can still have some hair right there. Anyways. Wow. Not a good idea. Not a ponytail. Oh, man. All right. We'll see. We'll see. We'll see. I don't need this roasting of my hair. Some of my hair came off. So, last question, and we'll call it a day here. Do you think I'm smart on a scale of 1 to 10? That's a tough question, Blake. Blake asked if where he lies on the scale of 1 to 10. Blake, is this a logarithmic scale? All right, last question. Last question. We got wire C and D, this is number 53, by the way, are made of different materials and have different lengths, LC, LD. They both have the same length. The resistivities are different, and the diameters are different. And they want to know, what is the voltage? What is the potential difference between points 1 and 2? So here's what I'm seeing. I'm seeing this picture right here, where you've got this part of the wire, and you've got a smaller part of the wire, like that. All of the current is going to have to go through here and here. So the current in the circuit is not going to change. Another picture I could symbolize this is like this. This could be resistor 1, and this could be resistor 2. Because they have different resistivities, they're going to have different resistances as well. So I see two things that are combined in series. And so if we want to find the voltage across C, we're going to write the current I times the resistance C, where this is resistance C, and this is going to be resistance D. So to find this voltage here, we need to multiply these two numbers together. And I believe they told us what the current was. The current in this question is 2 amps. So I equals 2 amps is going through here and here. So we know I, we need to figure out what RC is. To solve for RC, you use the equation for resistivity, which is resistance for C times the length at C divided by the cross-sectional area AC. And that's going to equal rho C times LC divided by pi RC squared. I'm not forgetting the squared this time. And so resistance here is going to equal 2.55 ohms. And so the voltage C, when you multiply this and this together, is going to be a whopping 5.1 volts. Okay? And so to do the next part, you do exactly the same thing. So to find the voltage at D, it's going to be I times RD now. And you can solve for RD using the same kind of equation here. Just replace the C terms with the D terms, and you will get resistance Yeah, we can see that. Resistance at D is going to equal 5.09 ohms. And the voltage, when you multiply that by the current I, is going to be 10.2 volts. Hey, put that down and focus. I can see you. I know you're not paying attention. Pay attention, please. Okay. That was part A, B, C. Now C and D. For C and D, to find the power lost in C, to find the power lost in C, so how much power is being lost there, you can use the equation I squared times RC. You can also use the equation V squared over R, because we know both of those. So it's up to you. And so plugging it in, you're going to get 10 watts of power lost at C and 20 watts lost I squared times RD. 20 watts lost there. Okay, so that's enough for today. It was just supposed to be a quick 30-minute thing. Next week, I will, again, for those of you who kind of came in late, I'm going to do something like this. I will then save it, and it'll still be available, even if you're not able to live stream it. This should still be up, and you can share it with some of your other friends as well. Also, what do you think of this? I should start a new Google Classroom, and anybody that wants to watch these videos can be a part of that Google Classroom, but you guys are going to have to share that. You guys are going to have to share that with other students. I can only do that with my class. So if you send it to some of your other friends, they will also have that. Is this daily? This will be Monday through Friday. We still have an AP exam. I don't know if it's at home. I don't know what's going on, but I'm going to continue just like we did with the AP exam. And then I'm going to use Zoom. I'm going to use Zoom for doing very specific questions, so test related. I'll have my FlexCam posted on my desk, and we'll do something similar to Khan Academy. And so again, there's only, I think for Zoom, it's about 100 people limit. So we'll do test questions on Zoom, and that will probably be like every other day or something like that. But for the YouTube stream, we'll try to do that Monday through Friday, and I'll go over all the material that we're supposed to do. Are we good with that? So Zoe's asking, what time will I do these videos? Maybe I should like do once people are all in that Google Classroom that we make, maybe I could do a poll and ask where most people would like me to do those videos. I'm thinking like we should stick to our physics C time that we normally do. So physics C was between 6th period until 7th period. So it was from 12 until 124. So you don't have to watch the whole video if you know what you're doing. What I'll do is I'll put some questions up on the board so you can pretend like we just never left physics C. We never left physics C. And we'll just do it like our normal schedule. Now, if you can't do it that time and there's a lot of people, let me know about it, and we might do like an evening stream every once in a while as well. But if you can't make it to the live stream, as I said, I'll post all of these so you can still watch them. And if you have any comments, just put a time mark on there and tell me what your specific question is, and then I'll respond to you that way as well. But I think live stream is kind of the best thing because I can answer your guys' questions right away. Yeah, The other thing is somebody wrote something. Try to keep these comments professional. Don't say anything about other teachers because you don't know if other teachers are going to be watching this. You don't know. So try to not write anything inappropriate or anything like that. This is meant for you to learn. Okay? So if that's it, I guess that's it for now. Did it all go well? Is there anything you want to tell me? All right, we got one like here. Somebody called me scary. The some physics teachers collab video. Nah, I don't talk to them, man. What are you talking about? Okay, so with that then, is the voice clear? Is what's being posted here clear? All right. So with that then, probably Saturday or Sunday, on Saturday or Sunday, I'm going to tell you the list of like the next topics. And I'll try to let you know when the live streams are going to be as well. So again, it's going to be around 12 o'clock noon. But if there's a specific problem you have, we can adjust that as well. I thought 12 o'clock because I need some time to wake up now. I get to stay home just like you guys. So we'll keep it at 12, but we can adjust it if we need to. Other than that, that's it. I will give you some questions to do before the live stream starts, so that way I give you time to look at it beforehand. And then we'll just do like I normally teach a class. I give you some questions, you do them, we go over them, and we go from there. Good? If that's good, you guys can go, and thank you for the test. It seems like it's working pretty well. I will see you guys on Monday. Take care. Bye.